Yeah, so I'm Eric again, work with the Communication and Cyber Technologies Data Science Group. And here we're today talking about managing complicated research workflows in R using the targets package. I gave this workshop in, I think, 2022, and a lot has changed with targets. There have been a lot of improvements, and so I'm really excited to kind of deliver this again. Oops, let me bring up my notes here. All right, so a little bit more about CCT data science. I do just want to give a mention to what we do. So in addition to offering workshops, we have drop-in hours every week where you are all welcome to come and ask questions. We do them virtually. Yeah, come ask your questions about R, about other programming languages, about just sort of general data management questions. If you are in ALVSKI, which this acronym includes the CALES, College of Agriculture, Environment and Life Sciences, and also the Experiment Station and the extension offices. If you're in that group, you can work with us on an incubator project. So these are projects that are pre-funded, so they're free for you for like short-term kind of work where we'll work with you on some kind of data science project. And there's a lot of examples of stuff we've done in the past on our website. And we also are available for collaboration on funded projects. So you can pay for our time to help you out with some sort of data science aspect of of your project. And before I forget, I will put links to the slides here as well. And thanks, Christina, for sharing info about the program. Yeah, so that's a little bit about us. And then before we really get started, these are the packages our packages we're going to be using today. None of them should take very long to install. I'll paste some R code that might paste correctly. I don't know. Sometimes pasting in Zoom chat, things get, quotation marks get turned into smart quotes or something, but you should be able to paste that in and install. And even if you already have some of these packages installed, I don't think any of these take very long. So I don't think there's a huge risk in just kind of pasting this in and getting the most updated versions of all these packages. So yeah, go ahead, open up RStudio, get that going while we talk for a little bit. That can kind of happen in the background. And if you run into any issues installing packages, we'll address those later. I'll check in, make sure everybody's got them installed. So today, what are we going to do? First of all, I think it's important to get some context and understand what problems, targets, and just sort of the concept of workflow management in general is trying to solve, so that you know when it's useful for you. You're going to be able to set up a simple project using targets, view the dependency graph, and don't worry if you don't know what that means, we'll explain that, and actually run this workflow today. And sort of in order to get there, you'll learn to write an R function. You probably used functions in R, but maybe you haven't created your own before. And it's actually not that difficult, and is a useful skill to know, even outside of the context of using the targets package. So we'll learn to do that. And then I just want to give you like an awareness of the possibilities that you have with targets. So things like parallelizing your workflows, using the HPC at University of Arizona to run steps in your workflow in parallel, using cloud storage, iterating, so doing like things like simulation studies or iterating over multiple files or yeah, steps like that. Bayesian analysis, geospatial analysis. There's lots of possibilities. So I just want to kind of give you an awareness of what's out there. And of course, give you plenty of places to go to learn more and get help with targets. So I've got like a bunch of stuff that I'd love to talk about. I already know that there's not going to be time for everything, and that's okay. So I also want to just say I encourage everybody to like interrupt me at any time, ask questions, and chat. You'll all get a lot more out of this if you're kind of asking questions than just listening to me talk on and on. So please do interrupt. And yeah, you can also ask questions in the chat. Christina's going to monitor the chat and let me know if somebody has questions, but you can also do the like hand raise thing on Zoom or whatever. So let me talk a little bit about the sort of context for this. So if you have taken a workshop or learned about sort of reproducible analysis, you may have heard some of this stuff, but we in our group we talk about sort of working towards reproducibility because there's no real like end goal like reproducible, not reproducible. There's always things you can do. So trying to make your research more reproducible is beneficial for you. So future you, when you have some changes you have to make, or reviewers of your manuscript request some sort of different analysis, if your research is reproducible, if your code is reproducible, it makes it a lot easier. It's also great for your collaborators to make it easier for them to contribute and help you out. And it's good for the greater community, right? Don't we all love it when you read a great paper and they've got a supplemental that has their R code in it and you run it and it sort of works, right? It just works. That's an amazing, amazing thing. So we want to enable y'all to do that. And if you've taken one of our workshops on sort of reproducible research, you might already have something like this. So here's an example repository or example, analysis project where you've got your data and you've got your R scripts numbered in kind of the order that they should be run in. So you've got this one that's exploratory data analysis labeled 00, and then you've got 01 wrangle data, 02 models.r, and 03 plots.r, and then we've got a manuscript there written as an R Markdown document. So we're being very fancy here. This is great, right? The only thing here to note is that this 02 models.r script takes a really long time to run, takes like 8 hours or something, right? And so we really want to avoid rerunning that as often as possible. Okay, so this happens. So you have this guy here is maybe your PI or a collaborator that says, "Hey, I just found a few errors in the field data and fixed them. Can you go ahead and run that analysis again?" And you're like, "No problem. I've got this reproducible workflow. Only thing is it might take a while." So you start looking at it and start thinking about, okay, which of these steps do I actually need to rerun? What stuff can I skip? And maybe you decide, what, the heck with it. I'll just run the whole thing, just go home. It'll be done in the morning, right? And that's fine. So you start that, you kick that off, and you go get a coffee or something. And you come back and you have another message. "Hey, sorry to do this, but found one more mistake in the data." And this inevitably repeats. And if it's not mistakes in the data, it's tweaks to the models, it's changes to the way the plots look to get things ready for publication, right? You're always going to be tweaking things. Things are going to be evolving. And it gets annoying when you have to rerun this whole thing. Okay, another scenario 2. Same kind of starting point. We got our nice numbered scripts, but then the complexity of your project grows, right? Now you've got 4 different kinds of models you're trying out, and you've got different plots, and you're trying to do this numbering thing where you're like 02A, 02B, 023. But now it gets really complicated to figure out manually with your own brain how these files are all related and kind of what order to run stuff in when you need to repeat some analysis. So these are the kinds of problems that Targets is really good at solving, and just workflow management in general. So this concept of a workflow manager is a program that can automatically detect the dependencies. So dependencies here meaning like which steps depend on which steps. So we have to, wrangle the data before we can run the model, before we can do the plot. And they can run your entire analysis with one master command. You can just hit go and it'll run the whole thing and automatically skip any steps that don't need to be rerun, that are still up to date, right? And they're usually scalable, meaning that you could run this workflow on your laptop. You could run it on the university high performance computing, setup. You could run it in a cloud. Yeah. So here's, our example workflow. This is basically this sort of this, right? Where instead of this mess where we're trying to figure it out manually, we've got Targets has figured out that in order to tidy data, we've got to have the raw data complete, and then we can run these 3 models, and then if we have those models, we can run the plots, and then if we have everything, we can create a report. So Targets is not the only workflow manager. Targets is specific to R. There are other ones like Nextflow, which is can be used with any language. There's a snake make, which is for Python. I haven't used either of those, so I can't really comment on how they compare. But yeah. So we're going to, I just want you to just try it out. Just want you to get your hands on it right now. So for those of you that have not, that came in a little bit later, I'll just post the last thing that was in the chat, which is these are the packages that we're going to be using today. So you can install those. I think that's all of them. So what we're going to do, and I'll walk you through this the first time here, is I have some demos set up, and this command is going to install, or it's going to download that demo and open it up as an RStudio project for you. And so I'll just go through it with you, but and then I'll give you a moment to try it out. So here I am in RStudio. I've pasted that in, and I'll paste that in the chat as well. And I hit go, hit enter here to run that command. It'll say it's going to download that onto my desktop. That's fine with me. So I will choose number one for yup. Your yeses and nos will be in different order. You have to like read them and figure out which one is the yes answer. And it'll download it, and then it'll ask me if it wants to delete, if I want it to delete the zip file for me, and I'll say, sure, 3, absolutely. And then it will go ahead and open up a new instance of RStudio, which I will over here. And that'll have some files already in it. And you can take a look at this targets.r and kind of take a look at it. So go ahead and everybody, go ahead and run that command and download the thing, delete the zip file if you want, and give me like a green check reaction on Zoom or a thumbs up or something like that once you've done that.
I'm sorry, I missed where is the command?
Oh yeah, I put it in the Zoom chat. So it's this, let's go back. I'll put it in the slide here. So it says use this package, which you may need to install the use this package if you don't have it already. Use course, CCT data science / targets / demo.
And selection is what?
It'll first ask you if it's okay to download it to your desktop, and you can say yes. And then it'll next ask you if it's okay to delete the zip file, and you can also say yes to that. So once you've got it downloaded, you should see in your files pane, you should be able to see this _targets.r file. And this is where the workflow is defined. But before we look at that, I'm just going to run the workflow. So I can load the targets package with library targets. And then we can do, well, we can view the workflow with tar viz network. And we get this nice kind of interactive network diagram that shows us the triangles here are functions, and the circles in this are called stems. And we see how they're related to each other. And then I can run tar _make to run this whole workflow. And then I can look at the results with, for example, tar _read lm full. So I can see that, or I can load it into my environment with tar _load lm full. And now over here, we've got lm full, and we can do stuff with it, like summary lm full, right? It's there in our environment. So yeah, and if we run tar _viz network one more time, we'll see everything is green because it's up to date. So everything's been run. And if you were to run it again, tar _make, we'll see that everything gets skipped because it's all up to date. There's no need to rerun any of those steps.
I got an error.
Oh no, what's your error, Christina?
It looked like when I first ran tar make, errored target file, errored pipeline. Something with the file? Because when I reran tar Viz Network, my diagram shows that the file in the upper left-hand corner is red.
Oh, do you have this penguins_raw.csv?
That's under data, right?
Yeah.
Yes,
Should
I
be.
do.
You do. Interesting.
Maybe I can just try running it again. And I don't know, did this happen for anyone else?
Well, Laura's got an error as a different one. Could not find packages bbmle in library paths. That just means that you don't have that package installed. So you can install it, install.packages, quotation marks, bbmle. And let me talk a little bit. So while Christina troubleshoots and Laura installs that package, let me just talk a little bit through what this file is doing here. So we're gonna make this ourselves a little bit later on, so we'll get more chances to understand it. But this is a very basic workflow. It has library targets here because all of these functions to define this pipeline are from the targets package. And here in this tar options set, there's lots of options we can set, but the only ones we really need to is to tell it which packages are actually needed by our workflow. And in this case, it has dplyr, janitor, and bbmle. And then tar source here is loading in all of the R scripts in the R folder. Nice. I see in the chat, Sumi also got the same error. Yeah, with bbmle not being installed and then rerunning it, and it worked. Yeah. So, okay, cool. Everybody's hopefully got it working. So let's take a look at this R folder, since that's what's happening here. So in this R folder, we have these two files, get data and fit models. And if we look at them, if we ignore the sort of this outside bit with the curly braces, in here just looks like kind of regular data wrangling code. So we're reading in a CSV, we're doing some, data wrangling to extract dates and convert things to factors and select certain columns, rename columns, blah, blah, blah. Yes, Raquel, excellent. That warning message is not a problem. Yeah, that is fine. That just means that you don't have our version 4.4.2, which is okay. Should all still work. So yeah, and then our fit models, again, like this just looks like a regular kind of linear regression model in here, but we've converted them into functions on the outside. So we'll talk about functions a little bit later. So that's like where the code is that does our stuff. And this is why we need dplyr and janitor and bbmle, because they're involved in some of these steps. There's some of these functions. So AIC tab here is from bbmle, the bbmle package. So now the last bit is this workflow definition, and it's a list of all of these tar_target functions. And so tar_target is defining steps in our workflow. So our first step is we're calling it file. This is the name we give it. It's kind of arbitrary, but we'll talk about naming things in a bit too. And it's just this file path to data/penguins_raw.csv. And we've told it this is a file. I'll talk about why in a bit. And then we've got a target or a step called data that uses our custom get data function that was defined in here. And it's connected to the previous one because we've used the name here, file, in our second step. And then we've got another step called lm_full, which uses this function that we've defined in fitmodels.r here called fit_lm_full, and it runs on data. And that's, again, how that's connected to this previous step. That's how targets knows that these two steps are connected, because we've used this step that we've created here in this next step. And then we've got another LM here. And then we've got this final step called AIC tab that uses two of the upstream targets here, LM full and LM main effects, and compares them by AIC. If you're not familiar with AIC or regression models, like, it doesn't matter. This is just an example workflow to show how these things are related to each other. So questions so far? I know it may be mysterious, but we will clarify, but I'd be happy to answer questions. Yeah, we got one from Prashit.
Yeah, Eric, with a lot of this stuff, at least I do it, by creating different R scripts and then run them separately by having
Yes.
a mother kind of, R script.
Mhm.
So what advantages do you see, or shall I wait until end of the presentation and figure out by myself what advantages?
Well, I'll show you one right now. Tell you what. So this is something you can try. You can go into that fit_models.r and change something. So for example, change the response variable from flipper length _millimeters to bill length _millimeters, right? So let's go ahead and do that. So instead of flipper length, we'll do just this one, I guess, up here. We'll do bill length. So that's another column in our data set, is bill length. And now when I run tar_viznetwork, it'll show us that this has changed. So therefore, this is out of date, and therefore, this is out of date. So you could do this, right? You could have a master script that just says, run the R script, source this R script, then source this R script, then source this R script. But there's no way in there to detect how things get outdated, right?
Yeah.
I think. So this is the main benefit. So then when we run tar make again, you'll see it's skipping some of the targets, and it's only rerunning the ones that were outdated. So it's rerunning this LM full. So it dispatched LM full, completed it in 0.006 seconds, and then it dispatched AIC tab and reran that and completed that in 0.005 seconds. But it didn't rerun any of the other stuff, right? Because that was all up to date. So that's one benefit. So hopefully that's helpful, and we'll see more differences. But you're right. This is a very basic version of this. Would be to just have an R script that sources a bunch of other R scripts, and that is a good thing to do for sure. This kind of takes it another step further and is useful when we have really long running stuff and complicated workflows. So,
thank you.
Any other questions so far? Okay. So let me talk a little bit about how it all works. So each of these steps often are called targets. So a little confusing. The name of the package is targets, but each of those steps is called a target. And the result of each of those steps is an R object. And it's stored by default in this underscore targets folder. So you may have noticed this got created the first time you ran tar make. This is a folder that you really shouldn't be touching manually. This is something that's automatically generated by the targets package, but I'll just show you that it has inside of it, if we go into the objects folder, these are all the things that are created. And you could actually technically go read RDS underscore targets / objects / LM full, and it reads it in. So just kind of unveiling a little bit of like how it works behind the scenes. But again, we're not going to do this. This is not the way to do that. If we want to actually get that target, the way to do it is to go tar read LM full. That's going to be a better way to do it. Okay. So yeah, that is the default, again, is saving them as these RDS files, which if you haven't encountered before, it's a way that you can save any R object. It could be a data frame, a list, a model output, whatever. But there's lots of other options of formats that you can save things as. Yeah. Okay. So we talked about that underscore targets.r a little bit. That's where we configure and define the workflow. The R folder is where you put R scripts that have in them custom functions, and I'll talk about writing functions in a bit. And then that underscore targets folder is something that's automatically generated, and you shouldn't really touch, edit on your own. And it's something that you probably don't want to track in version control. So if you're using Git or for a project, you might notice that it has this .gitignore file that says basically don't track any of this stuff because those are big files. And if you don't use Git, that's okay. You don't have to worry about that. Don't have to worry about what that means, but it's there for you just in case you need it. Okay. So the next piece of this is to give you guys an opportunity to refactor a more traditional analysis project to use targets. So this is a good way to like learn how this all works. So what is refactoring? Refactoring is when you restructure some code so that it changes how it works or improves how it works, but it doesn't alter the functionality. So what I mean in this case is we're going to just take a workflow that is more traditional, like what I showed in those first images where you've got like numbered scripts, and instead use targets. And it's going to make the same, it's going to produce the same results, do the same thing. But we're gonna fix it up to use targets. So there's another course here that you can repeat these steps again. So this is a different one. So we're done with the demo for now, but you can use that here if you have it open. You can paste what I just put in the meeting chat, and we'll go through that same thing. It'll say, are you cool with downloading it to the desktop? I'm going to say yes. And then it'll say, do you want to delete the zip file? And I'm going to say, yep. So, and that'll open again in a separate window. And I will move it. Sorry, guys, for the screen switching. We'll put it right there. So this one looks a little bit different. We don't have targets set up yet. We just have these 3 scripts. So go ahead and run this and like take a moment to look around and just try to figure out what this analysis project is doing. And I'll just give us like 3 minutes to take a look at that. Once you're satisfied, you can give me a green check mark on Zoom and I'll know we can move on. Okay, so hopefully you've been able to download this and take a look at kind of what it's doing. So we've got these nicely numbered scripts. I think it's nice. And hopefully you can see that what it's kind of doing here is we've got some raw data that has something to do with maple trees. And in this first script, 01 read wrangle data, it's getting read in. And we're doing some stuff with cleaning the column names and getting rid of some columns and changing some values to NAs, and then like converting things to factors, it looks like, and spitting out that data frame, saving it as an RDS file. So you could actually run this. If I click the source button, it'll run all of the code, or you could go through line by line and use like Command Enter to run them all. But it creates this this Maples data frame, and it also saves out this maples.rds, right? So this is something, again, you could do this without targets. You can just save RDS files, and then I could restart R even here. And say, well, hey, I'm done with that. And then I can go to my next script here, and look, it starts with reading in that RDS file that we saved. So that's kind of cool. So we could, again, kind of look at this, see what it's doing. Looks like it's making some plots. We got this box plot. We got summary table of some kind. Let's see what that looks like. Yeah, it's got like some means and standard deviations and like counts here. Cool. And then third one here, again, starts by loading some packages and then reading in that .rds file. And then, I don't know, looks like we're calculating total mass and fitting a model and doing an ANOVA and getting the results out as a table here, as a data frame. And then there's another plot. Okay, cool, with some confidence intervals, right? So we don't have to know exactly what this means, what this is showing, but hopefully it all works for you guys. Hopefully you can run this code and it works. You may need to install these packages if you didn't already. So this is a good point to, potentially do that. So we've got like a pretty relatively simple analysis that's like, I would say pretty traditional, right? So we've got these scripts that we run in some order, and we could do something even, like Prashit's had and just have a master script that sources all three of those in order. That would be a good improvement. But what we're going to do is set it up to use targets. And so refactoring a project to use targets or just using targets from the beginning, it is a little bit of a paradigm shift. So, the more you use it, the more you practice with it, the more beneficial it is because it's easier to think in that way. So it's a little bit of a paradigm shift, right? We have a different way of doing things. We have to use functions and stuff. So we're going to walk through doing that. So these are the steps that we're going to take. First, there's a really handy use targets function in the targets package that will give you like a template targets.r file to work with. Then we're going to figure out what packages are used by our code and put them in that tar options set. We saw that in the demo. We're going to convert those R scripts sort of bit by bit into functions. And we'll talk about how to do that. And then we're going to add targets to our workflow. We're going to add steps to our workflow with that tar target function. And we're going to be able to run our thing with tar make and then, possibly run into errors and sort of debug things. So that's like the process. And we're going to walk through this process together step by step. So the first step is to run use targets. So let's all do that. So I can just go in here and library targets to load the targets package. And then I can do use underscore targets. And it'll create a underscore targets.r file and open it up for you and tell you to modify it. So go ahead and do that and take a moment to look through it. And then we'll kind of look through it together. It gives you a lot of stuff, a lot of comments. So what have we got here? We have this sort of auto-generated underscore targets.r file that's used to define our pipeline. Right now, what does it have in it? It's got library targets. So this is telling you this is where you would load packages that are required to define the pipeline. Target types here is commented out. I'll talk about target types a little bit later on. We can ignore that for now. And then tar option set has like a lot of stuff in it, a lot of information in it. Right now, the only thing that's not commented out is packages. And so this we've seen before in the demo where we define or we tell it which packages that our code needs to actually work. And it puts in just as a default there, Tibble. It doesn't know that we need that. In fact, we don't in this project. It's just a placeholder. There's other information about sort of the default format and how to run things in parallel or on an HPC. And we will talk about that all later. Then we've got this tar source to run our scripts in the R folder. And we've got our pipeline definition list. And these, again, are just placeholders, right? We can run this. So you could run tar underscore make and it'll run. But what it's going to be doing here is making a data set of random X and Y variables and then getting the coefficients from a linear model. So we can run it and then we can say tar read model. That's what it gives us, right? This is not what we want it to do. We wanted to replicate the analysis here, but that's our first step. Anybody not able to get this working, the use targets, please speak up.
I got all the messages, but I do not know how to get the beautiful graph you got.
The beautiful graph. Oh, that was from running through these. So you could open up read wrangle data, click source, and then go to the second one and click source. Maybe it won't. Maybe you have to run it line by line. So I used Command Enter or Control Enter on Windows to just run the code in these. So this is a good thing to check to see that it works, because if it doesn't work on your computer, it's probably because you are missing one of the packages that it needs.
Oh, I ran them all and I don't see the beautiful chart.
So
Okay,
if you ran them, did you just run them by clicking the source button?
yes.
Okay, so when you do that, it like happens in the background and you don't get to see the graphs. So if you want to see the graph, you open up this 02 exploratory data analysis and you have to actually run. So I'm using Command Enter, but you could also like select the code and click the run button here, and that should show you the
Okay.
graph. Yeah.
Got it. Thank you.
Yep. So we'll get to recreating this in targets eventually. Okay, so any other issues with the use targets? Or you ready to move on? Okay. So next step is to figure out what packages are needed by the workflow and add them to that packages argument. So again, that tibble that was there as a default is, we can just delete that. We don't actually need that. So go ahead and look through those scripts and figure out what packages we need to put in this packages argument. And just take, a couple minutes to do that. So like, for example, I'm looking here in this 02 exploratory analysis and I see that we need ggplot2. So I would go and make sure that we have in here ggplot2, right? So take a few moments to do that, add those packages in there. And yeah, if you don't have them installed, this is also a good time to do that.
Sorry if you already said this and I missed it, but in the targets.r script, there's the load packages required to define the pipeline. And then there's the set target options, which is where you read in all the packages are needed to run the scripts within the pipeline. What are cases where you'd want to read things in under the first set of,
so
like targets make sense to
I think that it would technically work actually if you did it all up here, like library ggplot2, library dplyr. I actually think this works. I can't remember, but here's why you might want to use the packages argument. So maybe you've got a package that is really big, takes a long time to load, or it conflicts with some other package and you only need it for one of your steps. So you can set your packages here in tar option set and then they apply to every step. But you could also in each target say, well, this one only needs, ggplot2 or whatever. So you can have like different packages that are used for different steps potentially if you need to. So that's where using that packages argument is a little bit nicer. Now, the downside is like, they're character strings instead of whatever library ggplot2. Now, things that have to go in here is any functions that are used in this file. So if I were to like outside of these tar underscore target functions, right? So, if there was anything that's sort of like outside of our workflow definition, if you need a package for that, you have to load it here. So we'll talk about target types and other extensions to targets. That's typically what you'd load here. Or like they mention using crew to run in parallel, like you'd load crew out here too. So, and we'll talk about crew. We'll get to that.
Cool, that makes sense. Thank you.
Okay, so I'll just go through this real quick. Like I said, I don't think we need tibble. We need for this one, we need dplyr and janitor. Dplyr, janitor, and we need ggplot2, and we need car and broom, it looks like. So. Okay, so hopefully everybody's got a packages argument that looks something like this. I'll go ahead and might as well paste this in the chat just in case you'd like to copy and paste. Cool. So that's step one, or step two, really. Actually, step one was use targets. So next, let's talk about custom functions. So if you've probably used functions in R, right? So mean is a function, standard deviation, right, with SD. LM is a function. We've seen a bunch of functions, but maybe you haven't created your own. you can create your own functions with the function. So this is what it looks like to make a function. It's a very basic one, right? You would never really want to create this, but we're making up the name of the function here. I can call it whatever I want. I've called it add_10. And then I'm assigning to that function here. And then in the parentheses, I get to decide what the arguments are called. So arguments are like, if we look at a help file for mean or something like that, we can see that the first argument is called x here, but we've also got an argument called trim and one called NARM. So we get to define those. We get to decide what they're called here. And then we've got curly braces, and inside of the curly braces, we have code, and that's just whatever the function does, and we can reference the sort of inputs to it. So x here is going to be whatever we put in to x. So once I run this code, it creates a function, and then we can do what we want with it. So add_10, we can say x equals 13, and it'll give us 23 out. And so it's taking the input, plugging it in, and giving us that output. You can also create functions with multiple arguments, of course. So here's another weird one that you'd probably never create. I called it 2 fractional power. It takes x, a numerator and a denominator, and you can kind of see what it does. So like if we do 2 fractional power 27, 1, and 3, it's going to do x to the power of 1/3, like the cubed root of x, right? Cubed root of 27. And so the important, you notice here, there's like multiple lines in this function. The most important thing is that the last thing like returns a value. So we wouldn't want to assign this to something because then it's not going to actually show us the result. It's not going to give the result. So any function has to end, if you want it to, create a result, it needs to end with creating something. And for targets, we always have to have a function that returns something, some kind of object. Now, when you're creating functions, it's a good idea to use like some kind of naming convention. Verbs are usually good for functions because they're doing something. It's a good idea to make the function arguments the same as target names, and I'll show you what that looks like. I'll go back to the demo and show you what that looks like in a second. And it's a good idea always to write notes for yourself and for other people about what the heck the function does. So this is like not a great example where we've got a function that's called M1 and it takes this argument X and it fits this linear model with the data is equals X. It's not really clear what that does from the name and the argument. This is a much better example where we've named our function fit_model. So it's a verb now. It's saying fit the model. And it takes this argument called data_clean, which in this case might be another target that we've created from wrangling our data. So for example, when we were looking at the demo thing here, we have this function called fit_lm_full, and it takes this argument data, which is this here is data. Like it doesn't have to be called the same thing, right? We could call this, X or whatever, and then we just have to change it in here also. And this would still work, but it's more convenient sometimes if this has the same name as the target that's upstream of it that we're going to use. And we'll see why when we talk about debugging a little bit. So this is a thing about targets. This is like the major hurdle, right? Is that you have to write your code as functions really for it to work well. And I know not everybody's used to thinking this way. I can tell you there's a lot of benefits to it besides just being able to use targets. It helps you kind of chunk your stuff into pieces and like make things very modular. It helps you reduce repetition in your code sometimes. So it's actually there's actually a lot of benefits, even though it is kind of like a little bit of a hurdle, and it's something that gets easier the more you practice with it. These functions don't have to be that good. They have to be good enough, right? So they don't have to be like super reusable. We don't have to have like, input validation to make sure somebody doesn't, instead of providing a data frame in this function, they provide a, a number. Like, we don't have to worry about that because the function is just for you. And so it doesn't have to be good or reusable. It can just be our data wrangling code, but we just wrap it up in some curly braces and add function there, right? So we're gonna practice doing exactly that. We are going to open up the that 01 read wrangle data code, and I'd like you to try to convert that into a function. You can decide what you want to call it, but it will take file as an argument, which is a file path to the raw data, to that CSV file. And at the very end, it's going to spit out the Maples data frame. So take a moment to try that out. I'm going to set a timer here. And yeah, so try that out. If you get stuck, that's okay. We'll go through it together once you've given it a chance. But yeah, give it a try. Okay, if you haven't already, let me know what you decided to name your function. I see a lot of good names, all good. And if you haven't gotten it quite figured out, don't worry. I'm going to show you how I would do it. There's multiple ways to do this, just like with everything in R and programming in general. Like, there's no one correct way to do things. There's no one correct name for your function and all that. So I see names like read wrangle data, read wrangle, clean data. Those are all good names. And then Raquel asked in the chat about having basically a separate function for just reading in the file, and then maybe another function for wrangling the data. And that is also an option. So let me talk about those as I kind of go through how I would do this. So here's that read wrangle data.r. We could do it in here. I'm actually what I'm gonna do is I'm gonna create a new folder. So I clicked, by the way, if you don't know, you can create a new folder, and right here in the file pane. You could also just open up your Finder or Windows Explorer and do this. But I'm gonna create that R folder. And inside of there, I'm gonna create a new R script, and I'm gonna call it, I'll call mine read wrangle data too, just because that's what the script is called. It's kind of a long function name, but it's descriptive. So I am choosing to do a function that does both. But again, we don't have to do that. So I'll talk about that in a second. So I'm going to call my argument file. You could call it, I'm curious maybe what other people called that argument. Could be something really specific like maple data or whatever you want, as long as we use the same variable in our code. So I'm then going to copy and paste all of this bit into these curly braces. And the thing that I have to do to hook it up, right, to connect the code up to the argument here, is rather than hard coding this, I'm going to get rid of that and replace it with file. So if you called this, Maple CSV, well, then this needs to be called Maple CSV also. You can also, in functions, set a default by doing that. So this way, if you just ran read wrangle data, it's gonna load this particular file by default. In this case, we actually don't want to do that because we want to make sure that in our targets workflow that things are connected up correctly, right? We don't want it to default. We want it to use some upstream target instead of directly reading in that file. So, so this should work, and we should be able to source this code, run this. So I just hit Command Enter, it'll run the code, and then down here I could type read wrangle data and paste in our file there, and yep, that works. It spits out a data frame. That's how we can know if it works. But we're gonna comment this out or delete it or something so that all that's in here is the definition of our function. We might want to like leave a comment that said, reads in data, replaces 999 with NA, converts to factor, something like that for future selves. And then Raquel mentioned like asking about, well, is it okay to have a function that is just reading in the data and then a separate one that's doing the wrangling? Absolutely. And how much you sort of break up your code into functions, how much happens in a single function is up to you. And it's just, there's a lot of thoughts that, go into that in terms of like what makes sense, what's most readable, and also remembering that every step gets saved out as an object in R. So if like the size of the data becomes an issue, like you might want to do kind of fewer targets that do more in one step. But also if it's really long running, then you might want to break them apart. So it's like up to you how you do this. But we could have instead, we could have a wrangle data function that takes our, maples raw or something like that. And then we could, that's maples raw right here. And then we could have a separate function that's called read data. And that takes a file argument and or maple CSV argument or something. That is also totally fine. I'm going to go with the first option though for now, because I think that's based on function names. That's what most people did. So I just want to keep it similar. So let's move this back down there. Okay. Get rid of this. Cool, cool. We have a read wrangle data that takes maple CSV, reads it in, does the wrangling, spits out maples.
There's a question in the chat.
All right. Yes. Do we need the last maples? Yes, you do. Either that or you just get rid of this and do it like that. Either of those work. The reason why is if you were to just assign this to something, we were to do it like this, and we can test it out here. Nothing happens. It runs, but nothing happens. It's not returning anything. So functions always need to return some kind of value. And so we either need to put maples there at the end, or like I said, don't even assign it to something. So, yep, great questions. Very important. Okay, so we've got that first function. Ta-da, wonderful. Let's get rid of this. Let's make this full screen again. Cool. Now we get to define the workflow. So our next step is to create some targets. And so here's an example using, this is a different project, obviously. And so usually you only need to use the first two arguments of the tar target function. Oops, sorry. By the way, if you click on those in the slides, they go to help files. So you usually only need to use the first two arguments. So the first argument is the name. It's a name you get to make up. And then the second argument is the command, is what code is being run to generate that target, generate that object. The other time you'll use, the other argument you'll use commonly is the format argument. So here we have format equals file. And the reason that we have that is this causes, so without it, it's just, the command is just this text, right? Which this is valid R code, right? To just generate a character vector, length 1 character vector, right? That's all you need to do to generate that. But we're telling it this is a file. This isn't just regular R code. This isn't just a regular path string. This is a path to a file. So that means that targets will track that file. So if you were to change data in the CSV file, it would invalidate that target and it would invalidate anything downstream of it, so that you would have to, so those would know to rerun if you change the data. If you don't have format file, then only changing this text here would invalidate the target. So format equals file, or if it's a website, or a CSV that's on a website or something, you can use format equals URL, and it'll do the same kind of thing. Common mistake that I find is leaving a trailing comma here. So if there was a comma after this last target, I would get this really bizarre error. This is error running targets tar make. Last error, argument 5 is empty or something like that. And that's just because the list function in R doesn't let you do that. So it's annoying. It's not a great error message. So yeah, just make sure that last target doesn't have a comma after it. Similar to naming functions, naming targets, it's good to put some thought into it. It's nice to use nouns because they are to think of them as objects, and using sort of concise but descriptive target names. So something like data 1, data 2, data 3, that's not very descriptive. And something like histogram by site plot is kind of long. And so better options might be something like data underscore file, data underscore raw, data underscore clean, indicating that you're going kind of from the file to raw data to cleaned data. This would be like an example of where we had a separate reading function and wrangling function. And maybe something like plot, hist site. It's also worthwhile thinking about like the order of these things. So if we have a bunch of plots, putting plot at the beginning will help because there are some shortcuts in tar that we can use in tar make. So tar make, if you put nothing in it, it runs all the targets. But if you wanted to run just the targets starting with the word plot, there's a way to do that. So, you know, putting some thought in advance about how you name stuff. And again, this will become easier with practice. So now what I'd like you to do is to create a target for the file, that maple CSV, I can't remember exactly what it's called, and a target for your read wrangle function. And once you've gotten those, you can try it out by running tar viz network, by running tar make, try loading one of those in with tar read to see what it does. So you can use you've got this list here, and you're basically going to replace these two targets with your own. One that is just pointing to the file and has format equals file, and then one that uses your read wrangle function or whatever you called it in there. So take some time to do that. Maybe it won't take 10 minutes. I don't know. So just let me know when you feel done with that. And let me know if you run into any issues or problems or have questions.
I have a question.
Yes.
In the targets.r file,
Mm-hmm.
the list on line 50, I think it's line 57 for you. There's a comma. I thought you just said there's not supposed to be one.
Here, yes. Here, no. So this comma is going to screw
Okay.
things up.
Got it.
And
Yeah,
that's
yeah, yeah.
just because, like, if I just highlighted that and ran it, I would get this argument 3 is empty.
Got it. That makes sense.
And it's like, what the heck is that coming from? That's just how list works.
Oh,
There's some
trailing comma. Duh. Yeah,
a
that's what you
trailing
said.
comma. Yeah,
My bad.
exactly. So there's some alternatives to that in the Tarchetypes package that I'll mention later, but that's just something. I do this because I'll be working and then I'll like comment this out, and then all of a sudden this is broken because there's a comma here. So
Got
I
it.
run
Yeah.
it. I
So
run into that all the
common
time.
gotcha. Yeah.
Yeah.
Awesome. Thank you.
Yeah. I lost my timer on the other page, but or on the other slide. So I'm going to give it like one more minute, and then we'll go through it together. And yeah, Christina asked, how do you know if it worked? Well, you can run tar underscore make, and if you get no errors and you see that it ran both your targets, then you're good. And you can run tar underscore viz network, and hopefully you see the workflow that you imagined you were creating, and you get green symbols on there saying that they've been run and they're up to date. So, did anyone run into any errors? Ah, Christina did. Maple's not found. Okay. Christina, would you volunteer and would you be willing to share your screen and we can work through that together, see how you solve this and maybe try to figure out what's going on?
Yeah.
Cool.
Give me a second. Okay. So, okay. Oh, did I change something about this to not save it? Maybe that was my problem.
That might be it.
So, okay, so here is the targets list. So I have
Mhm.
for the data file,
Mhm.
and then for running the function on that file.
That looks good.
And
Is there?
then, Mhm.
Oh yeah, there is a closing parentheses on list. Okay. Yep. It was just
Yeah,
on the same
sorry,
line. No, that's fine.
it was, I just like made it
Uh-huh.
tighter. I guess, I don't know.
Let's see the read
Um,
wrangle then.
and I just realized I
Uh-huh.
didn't save this, so maybe that was my
I
problem.
wonder, let's try it again. So let's try tar make. Okay.
So it's
Let's try
skipping.
tar read. So what did we, let's go back to the targets.r and let's just make sure we actually called it that. You called it data. So tar read is
Oh,
you pass it the name of the target. So you're welcome to call that maples if you'd like. If that's something, right? Especially if you've got a complicated project where you have more than one data source, like that's great to name it something more specific. But in this case, you would need tar underscore read data to read it in. So try that.
oh, because, okay, yeah,
Yeah. So tar
this
read
right
data.
here.
Yep.
Oh, okay, so it
Tar
did
read
work. Got
data.
it.
And if you want to load it into your environment, it's tar underscore load data. And now you
Okay,
have the data object there. Yeah. So
got it.
hopefully that clarified for everybody that what you call stuff in the function doesn't really matter outside of the function. Like you could call it X, you could call it Y, you could call it whatever. It doesn't need to be the fact that we called it maples, that Christina called it maples in her function doesn't really affect anything for our pipeline. So the only reason that you might name it something specific is again just like for easier debugging. And I'll talk about that in a bit, but first we'll just show everyone. I'll share my screen and we'll just walk through it real quick. I know we saw Christina's solution there, which worked, but we'll just go through the process here. So I'm just going to get rid of these. I'm going to create a new one, tar underscore target, and I'm going to call this one, I'll call mine file underscore maples. And the command is just going to be data. Fun tip in RStudio, you can hit tab and you get file auto completion. It took me, I was like a decade of using R before I learned that that was a thing. So that's really cool. And then remember with this, we want format equals file so that it actually tracks changes to that CSV. R underscore target. Our next one, I'm going to call data underscore maples. And our command is going to be, I called it read wrangle data. So I'm going to say, oops, let's move this over here. I always like my targets.r file on the very left. Read wrangle data file maples. So I got to connect it up right. This has to be this for it to work. And you know what? I'm actually gonna, because I decided to call it file maples, I'm gonna make sure that in my function here, I'm actually gonna change that to file maples, file maples. Just for consistency. I really actually don't have to do this. Like it would still work fine, but I like it to be consistent for debugging, which we'll see in a second. So then I should be able to run tar viz network to see, oh, I got an error. What did I do wrong? Oh my goodness. Could not find function pipe. Did I not do my packages correctly? Interesting. What am I doing wrong? What am I doing wrong? That should work. Read wrangle data is in there. Got this, I got that. Oh, aha. I have this down here. So it's when it sources this, it's loading the function and then running the function. We don't actually want it to do that. We just want it to source the function, load it. So let's try that one more time. Yeah, okay, there we go. So that's that. And then if I do tar make, and tar viz network again. Beautiful, beautiful, beautiful. So if we're not going to have time to refactor this whole thing, but if you were to go and do this, work on this as an exercise on your own, the next step would be adding a target for this plot, for example, right? And this takes as input that Maples data, that cleaned Maples data. So that would be this data Maples target. So we'd have another target that was called like plot underscore Maples or something like that. And it would be a function. We'd have to convert this into a function. Plot Maples, something like that. That takes Maples or data Maples as the input. Something like this. We'd take our curly brace, plop it at the end here, boop, and call this data underscore Maples so that they're connected up correctly, right? And then we go and make a target for that and so on. Yeah, question, Laura.
Yeah, so I got my tar viz network to work. It ran, but for some reason it's not recognizing the function. I'm just concerned as to why, if you have time to help me figure out.
Is
what I
it
did.
in the R folder?
Oh no, I put it somewhere else. Thank you.
There we go. So it's by default, yeah. And so I'm editing it in here, right? Showing you this demo. And actually, that's not really what I want to do. Really, what I would want to do is create a new file in here in the R folder. It could actually all be in the same file, but I find it easier if I have a separate file for every function, just easier to find where stuff is. So yeah, I would actually want to create this in a new file. So this tar source here is only going to be loading stuff in this R folder. So the R folder often has kind of a special meaning in various different contexts of R stuff. You can tar source other things. So if you put it somewhere else, you could uncomment this and say tar source, my functions. And that would be sourcing some kind of file at the top level called my functions. You can do that if you want, but
Well, thank you.
yeah. So hopefully that kind of fixes it. Other questions? So like I said, we're not gonna have time to go through all of this together, but I encourage you to try it out, go through that exercise, and I will share with you if we look. So this is that same thing that you're looking at now, but on GitHub, and there is this like solutions here that I'll link to. I'll send you guys a follow-up email with the link to it. But we have the full kind of workflow worked out here with all the R functions worked out. So, and again, there's no right answer to how you do this. So yours is going to look different, but yeah, anyway. I will send that as a follow-up for sure, but I do want to, before we're done, talk a little bit about debugging. So we've saw a couple of errors, and it happens for sure. And they are sometimes very uninformative because everything's all kind of nested, right? You've got some code that's a mistake inside of a function that's running inside of a target that's running in this pipeline. And each of those targets, the way they work is they're run in a fresh R session. So it's often difficult to figure out what actually went wrong. One thing that you can do, and it will tell you when there's a mistake. In fact, I'm going to cause problems here on purpose, and we're just going to put in a typo, something like that. I think that's going to cause us an error. So now if I try to run tar make, yeah, we got this error, and you see what I mean. There's a lot of information here, and it's actually very difficult to figure out where's the actual error. What's the problem, right? It's here. Object watershed not found. It's got a Boston accent here. If you don't know, people from Boston kind of don't say their R's. Yeah, but it's hard to figure this out. So one thing that it tells us you can do is there's some options here. So tar errored, if I run that, I'm going to copy and paste that. It'll tell me which target errored. So that's kind of nice. I already knew that from up here. But I can also say, use this tar meta function here to show me metadata. And this will print out a data frame, but in that data frame, there's the actual error message that is caused. So that like helps a little bit, right? So it tells me there's an argument watershed as factor watershed. So something to do with that as factor watershed line. That is helpful. Another thing we can do for debugging that is really useful is set this option workspace on error equals true. So a workspace is basically what this is doing is anytime a target errors, it saves everything you need to run that target. And that includes any sort of upstream targets, any functions, packages, etc. And that lets you kind of load that and then interactively figure things out. So let's try it. Workspace on error is true. So let's say we couldn't figure that out. Let's go back up here and we'll add comma. Workspace on error is true. Save. And we'll try running it again this time. Tar make. This time we get the error again, but it says, I thought it would tell us. Oh yeah, recorded workspace, data maples. Cool. So we can use that. And so we can actually run now tar underscore workspace. And here's what I'll do is I'll clear my environment just so it's more obvious what happens. So my environment's empty. I don't have any R objects in there, but we can load tar workspace data maples. And you'll see that it loads in everything we need. It loads in the function, the read wrangle data function that I have, and it loads in the file maples. So I can then go read wrangle data, file maples, and I get like a nicer looking error message, right? This is something we're more used to, right? And I can go, oh, okay, now I know where that is. I can open up my read wrangle data function. I can find that line. Here it is. There's a typo, we fix it, right? So these workspaces are really useful. This is a relatively new thing in targets. I did not talk about this last time. It was much more difficult to debug things last time I gave this workshop. So that is awesome. So here's another example where we have an error that's uninformative in the context of targets, and then we can use a workspace and we get maybe a slightly more informative error in eval, mf parent frame object df cleaned not found. Okay. And then we can look at our function and what's the mistake here? Anybody spot it? Why are we getting this error? Anybody know? Yeah. So we called the argument data underscore clean, but actually in here, it's referencing something called df cleaned, which doesn't exist. So we would need to change these two things to be the same to connect up that code to the input. Yeah, so workspaces can help you with that. I also want to point out there are alternative ways to define that workflow that some of you may find more intuitive than a list of tar underscore target functions. So the tarchetypes package, which is an extension, and we saw here that this was like, we can uncomment this and make sure it's installed. That gives us some options. Tarchetypes has a bunch of stuff in it, but two of the nice things in it has these alternatives to using a list. So there's one function called tar plan, which doesn't care about trailing commas. Trailing commas don't error anymore. And it gives you this nice shortcut where if you don't need a file or format equals file argument or something like that, you can just say data equals and then your code, model equals your command, right? There's also a relatively newer tar underscore assign that allows you to use the assignment operator. And it works really well with sort of pipe-based workflows like tidy workflows. So you see in here, I'm creating a target called data underscore file, and then another target called data that references data underscore file. And all I have to do here is pipe that into tar underscore target. So it's a little bit weird. It's a little bit wacky. but it might work well for sort of smaller bits of code. You could also use your custom functions in here too. I'm just showing an example that really doesn't use any custom functions. So yeah, pretty useful. Okay. I just want to kind of wrap up a little bit here with showing and talking about some of the possibilities. And this is where please interrupt me if anything like catches your interest and you're like, tell me more. Happy to talk more about any of these things. So I mentioned tarchetypes. There's actually I'll show you real quick. If we search for Targetopia, I believe that'll do the trick. Get to this page. So I'll paste this in here. So this is a collection of packages that extend targets in different ways. So tarchetypes is one of them. But we also have stand targets and JAGS targets. So if any of you are do Bayesian analyses, these provide a bunch of kind of helpers for Bayesian analysis using stan or JAGS. So for example, they automatically create targets for multiple steps. So you would define in your targets.r file just a single tar stan MC or something like that. But what it actually does when you run it is it generates multiple targets that wrangle the data, run the MC chain, create a table of posterior draws, et cetera. They do a bunch of stuff. And I don't do Bayesian analysis, so I'm probably getting some of this wrong. But if you're interested, that's a great place to go. There's also GeoTargets. So GeoTargets is a project of mine and Nick Tierney's. And we created this to help you use packages like Terra and Stars, which are for geospatial analysis in R, and get them to work with targets and provide some like common workflows, like splitting things up into tiles and then merging them back together and so forth. Iteration. This is where, Prashit, you asked about like what are some of the benefits of targets. Here's another major one, is that we can do things like what they call dynamic branching. So if we have a large number of targets where they're basically all doing the same thing over different slices of data or different files or running a simulation or something like that, and it's too many targets for us to write out individually, we can use this thing called dynamic branching. So for example, if we wanted to fit a model to 100 bootstraps of data, so sampling from our data 100 times and then fitting the same model, we can do that really pretty easily with targets using the pattern argument here. So what this is doing is this first target is creating a target called data_boot. And it is, so the per package here is iterating. It's kind of like doing a for loop over 1 through 100. It's giving us basically 100 different data sets that are samples of our data. And randomly pulled out with replacement, so bootstrap samples. And this target, it's just one thing, but it's actually what it's returning if we were to load it with tar load, it would be a list of 100 data frames. And then a downstream target, without having to like explicitly reference a for loop or anything like that, we can just say fit lm full on our data boot. And as long as we say pattern equals map data boot, it's going to fit this for every one of those 100 bootstraps. And again, it's going to return a list. So we can do some really powerful stuff with dynamic branching iteration. Similarly, another really, really useful, powerful thing about targets is it makes it really easy to parallelize your workflows. So in this example, we've got a bunch of steps here that are not dependent on each other. So this Bayesian model, random forest model, and deep neural net steps, they could all be running at the same time, right? They all, as long as this tidy data has been finished, that target's done, all of these could be running in parallel on, 3 cores of your computer or on an HPC or something like that. And it's very easy to do that. So for example, if you just want to parallelize stuff on your own computer, all we need is in this tar option set, we set a controller. And the controllers are created by the crew package. And there's a bunch of different ones available, but this crew controller local is set up for just using concurrent R sessions on your computer. So you can say, let's do 3 workers. And now we have these like persistent workers that are set up, these 3 R sessions basically. And then when they're done with something, or they're not working on something, they get past the next job. And when they finish it, they're ready for another one. And so we can run these sort of things a lot faster, potentially, as long as we're not limited by CPU. And we can really scale that up really easily to be not, instead of running on 3 cores of our computer, be running on 3 different Slurm clusters on the HPC. So crew.cluster is another package that provides additional controllers. So crew controller Slurm. Slurm is the like job launcher that we use at University of Arizona for the high performance cluster computer. So if you've ever used that, you maybe have had to write out this bash script with all these different lines in it that set things like the memory and the wall time and partition and your account name. Well, crew controller Slurm allows you to set this all up in R with R code. You don't have to write that bash script. And what it'll do is launch 3 different Slurm jobs, or however many workers you set, and it will pass jobs, pass targets to them. They'll finish up, they'll return them back. We've created this template repository, which hopefully, if you're interested in this, hopefully this will guide you through using targets on the University of Arizona HPC specifically. So this is hopefully has like detailed enough instructions that you can just follow them and get something working if you're an HPC user. And if you do try it out and it works for you or it doesn't work, I'd love to hear how that went. And I have now lost my slides. They are here. Good. So yeah, HPC stuff. I love this aspect of it. I think this is wonderful. There's also the option to use cloud storage. So I showed you guys where that _target store is. Now that's on my computer only. And if I'm working on this project with a collaborator, and then they're going to have to rerun the whole pipeline to get all those targets on their computer. So they're going to have to run tarmake on their own computer. And maybe some of that stuff takes a long time to run. Maybe it's days or weeks or something like that. So that's maybe not convenient. So there is an option in targets to use cloud storage. So to use AWS, Amazon Web Services, or Google Cloud S3 buckets, or other S3 compatible buckets as well can be used. So that way, your results are actually not stored on your own computer, they're stored in the cloud. And so your collaborator can take your code and run tarmake on their computer, and it'll say skipped. It'll skip all the targets if they're all up to date, because it's actually not looking on that person's computer, it's looking in this cloud, this shared sort of cloud space. And you can actually version these buckets so that you can, if you roll back, if you make some changes, you revert some changes to your targets.r workflow, you don't have to recompute all the targets. They're all still there in the cloud potentially. So this is something I've dabbled in, but never really used in a project, but it seems like it would be very useful. So that's a little sampler. I just want to leave you with some thoughts about when to use targets. So some things to consider. One is, as you've seen with our creating of functions, this really works best when you have steps that produce some kind of object. So where targets might not be a great choice is if your steps include modifying like a database in place, where you have multiple steps like that, because targets really wants the output to be some kind of object that it can save in the target store. So that doesn't apply to every workflow, but it applies to, I think, most, or at least very many. You might also think about the benefits of parallelization. So if it's a workflow that can be highly parallelized, then that's going to be really useful for you to use targets. Consider your collaborators. So targets, there's pros and cons in terms of collaboration. Cons are, well, now your collaborators they have to learn one more tool. And you have to provide them maybe with some instructions about how to install targets and how to run tar make to like reproduce your results. But on the other hand, it forces you to modularize everything and write these functions. And that's actually really good because you could have everything working and you just need somebody to help you create a plot with your data. And so you can tell your collaborator, hey, here's all you got to do. Run tar make, run tar load data, and then use that and write some code to make a plot. And then I can take that and stick it in and add another target and, you know, add it to the workflow. So in some ways it might make it easier, some ways it might more difficult, but it's a thing to consider. And then as I've mentioned a couple times, like as you use targets more, you're going to be more likely to reach for it as a tool. Like I have been using it for a while now and I rarely hesitate to like, I'm like, cool, this is a targets workflow most of the time. At first, you know, you might want to not reach for it immediately unless it seems super obvious. But what'll happen is you'll get, once you start using targets, you'll start a project and say, I'm not sure if I want to use it. And you'll get to a point and you go, dang, I should have used targets. Now I'm going to refactor everything. So you'll come across this feeling, I think. I hope you like it. Not everybody does, but I think it's wonderful. I'll also leave you, I'm not going to share all these in the chat right now because I'll share the slides in a follow-up email, but these are some examples, like real life examples of manuscripts that have manuscripts and other projects and things that have used targets, just to get an idea of kind of like what's possible. And I tried to give examples of kind of different levels of complexity. And then I also want to remind everybody where you can go for help. So there is a targets manual, which is quite extensive. So this is the manual, the book. So I mentioned dynamic branching. There's a whole section on that. I mentioned distributed computing with HPC. There's a section on that. Cloud storage. There's a section on that. You do not need to read this all in order, but this is a great reference. And then that's the manual. There is also a reference website. So this is like the package website. You've maybe seen these for other R packages. This is where you would go for just like help files in a maybe nicer to read format, and you know, vignettes and things like that. So, and it also links to the manual. So the manual is really the real place to go for help. And there's also a discussion board here that is really active and is something that I monitor. So if you have a question there, it's a good place to search. Maybe somebody else has asked your question before and already has an answer for it, or you can ask something there and you know, somebody will answer it. And actually the person who develops targets, Will Landau, is very responsive and answers these questions pretty often. So that's really great. We've also got our drop-in hours every Wednesday afternoon that you're welcome to come to. And you can also, I have a link here to make an appointment with me if you want to do that. You can also email me, contact me other ways if you have questions about targets or you want help getting started or converting a project that you're using or just want to know, is it a good idea? Yeah, feel free to contact me. And then we've also got our mailing list there. I will put that in the chat in case you want to get updates on future workshops and things. We send emails out like quarterly, so not going to spam you too much, but we'll give you updates on upcoming workshops and other stuff we've got going on. Cool. Well, thank you for sticking with me for this whole time. I will hang out until 1 in case folks have questions, but that is all I have to say. So again, happy to answer any questions. And otherwise, you know, have a great day. And if you do use targets for a project, please let us know. I'd love to see the results and I'd love to link to your project on the slides the next time I do this workshop. So please let us know if you use it. Thanks.
Thanks, Eric.
Thank you.
Awesome. That was great.
Yep. Thank you. Stop recording. There we go.